you for letting me know. I usually have it dialed up, but different room than I normally teach in. Alrighty, so everybody go ahead and open idle. And as I've mentioned before, and as most of y'all know because you've already had fundamentals, this is the shell where you can type commands in if you want. Import turtle. We're not going to play with the turtles today, but you know, whatever. And you can type in 2 plus 2 and it'll tell you 4. Or you can do A is equal to 2 plus 2 and then type A and it'll show us 4. So we have the interactive mode, but we're going to hardly do very, very, very little in there. As we get along and we start defining functions, we're going to play with calling them from the shell rather than from the middle of the script that we write. So do a new file. Save as, I'm going to call mine August 24. It's already there. Alrighty. And so we're just going to play with some calculations. Operators. Operators are the mathematical symbols that hook up what are known as operands. The operators are things like plus and minus. I love using those grade school terms. Times and divide. There's another one, slash slash, which means floor division. Then there's star star, which means to the exponent of. A lot of people want to use that as exponent because you've been taught that's how you type exponents. Like if you want to type 123 squared, that's what you type. No, you use star star instead. So operators are the symbols and operands are the things that the operators hook up. What do I mean by that? Well, I'm going to create a variable and just store two numbers in it. Well, not two numbers. The result of this expression. 1 plus 2. That's the operator. 1 and 2 are the operands. So like just about every other syntax that was created in the English-speaking world, these are evaluated right to left. Or at least the right side of the equation, I should say, is evaluated, and then that value is copied over into the left. So it's going to do 1 plus 2 and then copy that into A. We want to see what that is. We're going to print A, comma, and then that value. But now we're going to print it in a slightly different way. There's more than one way of printing in Python. There's more than two ways of printing. We're going to use a formatted print. We're going to say A equals I don't want to get this wrong because suddenly the old C syntax for this jumped into my head. I cannot believe I flaked on that. It's alright. So let's say that we actually want to calculate it. Display it with 2 decimal points, like it was a dollar, dollars and cents. So I'm going to do this. %10.2 F. F means that this placeholder right here, which is going to get filled in with our variable, is going to be treated as though it was a floating point number. It'll be interesting to see what happens because A is actually an integer. We've talked very, very, very briefly about the differences between an integer and a float. Int is a whole number. A float is a number with a decimal point. And there are more technical terms for that, but that's good enough. Ints are whole numbers. Even if the decimal point is 0.0, it's treated as a float. In this language, it usually does not matter. You can use them interchangeably. In some languages, they are really picky. If you do integer divided by integer, it does something completely different than if you do a float divided by an integer. When you get to C++ and Java, you'll see that in action. So anyways, this syntax is a little bit different. I do not believe that we covered this in fundamentals, in my section of fundamentals, and probably not in the other folks either. I could be wrong about that. What this means, what this syntax means, is if you put a percent sign in the middle of a string that's being printed, it's called a formatted print, and this is a placeholder. This placeholder will be filled in by this variable. Let's see if it works, or if we got some nasty syntax here. I just typed Control S to save, and I'm going to do run module. All right, it said A is equal to, and it had all these spaces, 3.0. So what's going on there? Why do we have all the spaces? That's what the 10 means. So I'm going to make a comment here. Percent in a print is a formatted print. You can specify the width of the output and how many decimal places. More technical term would be precision of the output. Sometimes it makes no sense to have precision. If it's a word, if it's the word Jeff, you don't have a .00 on Jeff. We could play with printing it out. Let's change that A to quote Jeff, or your name, or whatever. Iron Man, I don't care, Tony. Here we go. Here it goes. It says must be a real number, not a string. Alrighty, a real number being either a float or an integer. So that gave us an error. And the reason why is because this F said, okay, I want you to be a number, and I'm going to treat it as though it needs to have 2 decimal places when I display it. This number here is how many wide it is. I'm going to put something before and after this placeholder just so we can count the number of spaces. I'm also going to shrink it down. 10's a little bit silly. So before that percent sign, I don't know, maybe what would look good? A parentheses. And after the F, another parentheses. Now that didn't work because I'm still printing out Jeff. I need to do what to fix this? That was dumb. I'm wanting to print out a number. What am I trying to print out? I need to change Jeff back to A. Yep. Alrighty. Alright, so here we go. We see that it is how many characters wide? 1, 2, 3, 4, 5, 6. That's what the 6 means. Reserve 6 places on the screen, and then 2 of them are going to be things after the decimal place. Then there's going to be the decimal point, which really leaves us with only 3 for the first part of the number, right? Because decimal followed by 2 more digits is 3, and we said 6 total. What happens if the number is larger? I'm going to put a large number in. Yeah, you know what it's going to do, right? It can't fit within 6 places. Well, it can because...
Would you use that for like if you want to show like pi or something, you just want to stop at a specific point?
Right. You know, if we calculate 1 divided by 3 and we don't want it to say 100.3s, then we would limit it. Or if we are displaying dollars and cents, we only want 2 decimal places. Or, you know, pi, we really only need 3.14159 rather than a whole bunch of things. So, you know, the more digits I put in here, I'm trying to make a point by typing a whole bunch of numbers in there. It is no longer 6 characters wide, right? If it can fit it into 6 places, it'll pad it out with spaces. But if it can't, too bad. You still want to see the number, so it goes ahead and fills up more than 6 spaces. You just have to kind of keep that in mind. I'm going to go back and change that to A one more time. Why? Because we calculated A, we may as well print it out. How about strings? We don't use %F. We use S for string. So name is equal to Snoopy. Print percent 10s, I want it to be 10 characters wide. I want it to be padded out with spaces until it fills up 10 on the screen. And then followed by a percent sign and followed by an S. And if you guys have ever done Java, you've seen this syntax before, but instead of the percent sign there, you put a comma. Same idea though. This syntax dates all the way back to 1970 in the C language.
So is the S and the F?
That's totally wrong. That's totally wrong. Thank you for catching it before I ran it. That's supposed to be name, because we're trying to print the name out.
Right. But where you have the percent 10s, is the S basically just standing for string?
Exactly. We're printing a string rather than a number. Here we were printing a number, so we used F. Here we're printing a string, so we used S.
If you want to use integer, you just put I. Is that right?
Yeah, let's give that a shot and see what happens if we try to print out a float like 1.2, but we say it's an I. Okay, here we see Snoopy. Snoopy's filled out to 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if you didn't want it right justified? What if you wanted the spaces to be tacked onto the end of it rather than the beginning? You can do that. Just copy that line, this print statement. If you want to be a wizard at using a keyboard, you put your cursor on the beginning of the line. You see where my cursor is, and then you hold the shift key and you press the down arrow. It highlights the entire line. If you're using Windows, if you're using Mac, I'm sure it's a different key sequence. Then you can do Control C for copy, and then you can move down a line by hitting the down arrow and do Control V for paste. Okay, but here's what I want to do. I'm going to put a minus sign there. Minus sign is going to mean left justify it, so the padding happens after it. Without the minus sign, it defaults to right justifying. It means that the spaces come in front of it. So there we see. We can't really tell that it padded it out. Well, we can, because when I try to highlight it, it'll only let me get 4 more characters because Snoopy is 6 in length. All right, why in the world would you care about the width of the string you're trying to print? And the answer to that is if you are trying to print columns, nicely lined up columns, it's nice to be able to say, okay, I want this column to be 10 wide and this column to be, 10 wide or 5 wide or whatever. And let's give an example of that. We're going to use a for loop. The majority of y'all have seen for loops before. So for x in range 1, 10, colon. Now I'm going to do a couple of calculations. Y is equal to x divided by 2. Z is equal to x divided by 3. Forgot my division symbol. And now I want to print those out. So I'm going to do this. Print, and I'm going to use some percent signs. So quote, these are all numbers. I'm going to go ahead and use F. We didn't experiment with I like I planned to. Percent F, percent F, percent F. Why? Because we're going to print out X, Y, and Z. So I have 3 placeholders. We need to specify 3 values that are going to fill in those placeholders. So again, we put the percent sign, but this syntax is a little bit weird. Since we have 3 placeholders to print, we have to put it inside parentheses. And I'm sorry, that's kind of weird. The other languages, Java and C and stuff like that, don't quite follow that scheme. And so our 3 variables, X, Y, Z. So you see what I did? I had percent, and then I'm printing out X, Y, and Z, so I included those in parentheses as well. And then 1 final trailing parentheses.
Is that just if you have more than one?
You could do it just for 1, but it's not necessary. If you have more than 1, it is mandatory. We could try it, take it out, but it's not going to work. Let's run it. Oh, and your instructor kind of forgot that it defaults to printing 6 decimal places already. So that wasn't a real big change. It printed it out as a table already just by using the %fs. But what if we only wanted 2 decimal places? Let's do that. Let's come in and do .2 on each one of these. So %.2f, %.2f, and %.2f. And there we have them. And then we decide that those are too squished together, that we wish we had some blank spaces between them. There are a couple of ways we could accomplish that. One is we could just come in and add some spaces. One like that, you know, that'd be cool. Or what we could do is we could say, okay, really I want this column to be 8 wide. And I want this column to be 8 wide. So you see now I'm making each one of these %8.2f, %8.2f, %8.2f. Now it's all nicely spaced out with lots of space to read it. So that's what formatted output is really nice for us. If you need to present, you know, a table worth of data, it can look really lousy. You know, names are of different length and stuff like that. So, you know, if you want to line things up into columns, what we did in previous classes is we tried to kind of fake it with the tab character. But tab doesn't really work. You may have seen it, because tab assumes, you know, every 4 or every 8 spaces, and doesn't always work. Okay, so that's formatted printing. Let's make a couple of more comments. %s for strings, %f for float. Let's give a good old %i a try. So one more print statement. Print %10i. And let's just make up a word after it, pounds, followed by the number 100. It should say 100 pounds when it prints. Let's see if that works. It did. It said 100 pounds. And it's expecting it to be an integer. Can we force it to have any decimal places? Can I type %10.2 pounds? Excuse me, %10.2i. Well, integers don't support decimal places, so I'm expecting that to generate an error. It didn't. What do you know? Alrighty. Python's a little bit more clever than Java, C, R in that regards. Anyways, if you're going to print out an I, you probably don't. It defaults. If you use I, it's just not going to print any decimal places. Let's see if that's true. Let's print out, instead of 100, let's make it 100.5 pounds. So you saw I removed that .2 there, right? I went back to it just being %10i. And then I changed that to 100.5. And I know I go fast. Slow me down if I'm typing too fast. Alright, so it didn't print any decimal points. Even though we told it to print out 0.5, since we said I, nope. Kind of supersedes the data type there. Saying you want an integer, I'm going to give you an integer. Even if, you know, you told it to have a decimal, you know, if you gave it a floating point value. Alrighty, anybody need any syntax error correction at this point? Alrighty. Uno momento.
I need a correction. Mine is not running.
Oh, okay, cool. Make me do my work. I appreciate it. So, %10 would cause the value to be padded with spaces on the left. %-10 would cause padding with spaces on the right. Trailing spaces rather than leading spaces. Okay, as is usual, The first chapter of a textbook is quite often a what is a computer kind of thing. We don't really need to know the what is a computer thing. You can read it. No reason not to. Then it talks a bit about coming up with a formula in order to solve a problem. Like the annual fuel consumed being the annual miles driven divided by the fuel efficiency. Stuff like that. So do read the chapter. I don't think I'm going to make any assignments from it. So chapter 2 is where it gets more fun. It starts talking about variables and arithmetic and strings and things like that. Very, very well worth reading. This is pretty much a reading assignment. Go ahead and read chapter 2. I don't care if you read it all over the weekend or whatever, but at least start digging into it. And I'm not going to go point by point through it. For one thing, a lot of it's rehash from fundamentals. But what we are going to do is we're going to go to our online text, and we're going to work through it pretty quickly. So if we go to content, textbooks, online textbook, follow the link. I wish it had opened in a separate page. Right click on it and do open link in new tab. Alright, here we go. And I'm jumping to chapter 2. So, variables, expressions, and statements, values, and types. Value is data, words, numbers, turtles, things like that. So a value is one of the basic things that a program works with. If you're not using any values, there's no reason to have the program. So, print 4. 4 is the value. Print is the function. If you don't know what type of value is, the interpreter can tell you. The interpreter meaning the shell. If I went back to the shell, if I do run Python shell, and I do type that, it's going to tell me that it's a string. If I do type that, it's going to tell me that it's an int. Do you need that functionality very often? No, but we have the concept already, I hope, that we have integers, floats, and strings as our 3 different data types. There are plenty more data types, but you have to import libraries in order to utilize them. So, data types, ints, floats, and strings. Strings being a sequence of characters between quotes, whether it's nothing, or 1,000 words long. The data types, each variable can hold a value. And last time and before I have mentioned what are the 3 things that a variable has. Come on, y'all fundies. I know you know this. Variable has 3 things. It has a name, it has a value, and a type. And behind the scenes, it also has a memory address assorted with it, but we don't really care about that. So a variable has 3 components that make it up. If it doesn't have a name, it's not a variable. If I just type 123 or 213 or whatever, don't type that. It's not a variable. It's a value. It has a type, but it doesn't have a name, so it's not a variable. You can store values in variables. So a variable is a named place in memory that has names, values, and types. So one of the most powerful features of a programming language is the ability to manipulate variables. First, computers didn't have named places in memory. You just had to know that, okay, if I'm writing to address number 10, I'm going to be writing to address number 10, and that's going to be my, you know, my age, whatever, you know. And so your computer had a very limited amount of places to write data, and you just had to remember as you were writing your program, okay, spot number 10 is my age. Spot number 17 might be my zip code, that kind of thing. That's for the birds. We don't want to do that. That's why we have variables. So an assignment statement creates a new variable and gives them values. I think somebody asked, why do we not declare our variables first? And it's because this language does not support that. We don't say int space pi. Well, it would be a float. Float space pi in order to dictate that pi is going to be a floating point number. Instead, the variable type is dependent upon the data, the value that is stored in it. And the variable type can change. It's totally legal to do, can I type up here? X is equal to 3, and then turn around and do X is equal to name. And then when I do print X, it prints out name. This overrode the previous value that was stored in X, and it even changed the type. It was an integer before, now it's a string. Python lets you do that. A lot of languages are pickier. Once you store an integer in something, you can't turn around and store a string in it. So variable names versus keywords. Variable names are the things you make up. Keywords are the things that make up the language. Those are the reserved words. Words like for, the for loop, while, if, define. All of those are keywords. They define the grammar of the language. And they are reserved. We can't use them for anything else. We can't make a variable called if. We could try. I'm going to go back up to that little trinket here and type if is equal to 3. No. Invalid syntax. While is equal to 0. Again, the keywords are reserved. You could go and Google up Python space reserved space words and get a list of, you know, all 70 of them or however many there are. When you're creating variables, there are some rules for what you can name them. I'm going to go back to the shell now. So Python shell, this is a legal variable name. A is equal to 1, 2, 3. A1, like the steak sauce, is a legal variable name. 1A is not a legal variable name. So a variable can, any identifier, a function name, a class name, a variable cannot begin with a number. That's a rule worth writing down. I'm going to go back to our little program and tack that on as a comment. Variable names, identifiers, can be letters and digits, but must start with a letter. And case matters. So if we go back to our little shell, now notice that I've stored a lowercase a1 here. So if I type a1 and hit enter, it's going to tell me that a1 is equal to 1, 2, 3. Good enough. But if I type capital A1, it says A1 is not defined. And there are some rules for friendly variable names. Don't mix up lowercase l's and 1's. If it looks like at all possible, like it might be interpreted as a 1 and you meant an L, then don't do that. For example, for some reason, say we had a variable called AL03. It's the third algorithm, right? AL standing for algorithm and 03, and we're going to just give that a value, whatever. That looks like A103, doesn't it? So if another programmer comes in and they try to print out A103, they're going to wonder why they get an error message when they do that. So be careful about uppercase O's and zeros and lowercase l's and 1's. Just make sure that it's real clear what you're going to use. And when I'm giving examples in class, if I want to use an L, I usually use a capital L just to make it blatantly obvious that that's what I mean and not a 1. Okay, I was wrong. I overestimated the number of keywords. Has 33 keywords. We've used a lot of these in fundamentals. You are going to use a lot of these in fundamental because you're taking fundamentals right now. And we know what that does. There should be an or. We've seen for. We've seen while. We've seen a great many of these. True and false, if and else, and elif, not. There's a couple that I don't think I even know what they do. Yield, lambda, you got me. Assert, I know what assert does. I've never used it in Python. So as we go along, you know, we're going to increase our knowledge of all the keywords. I doubt you're going to know every one of them unless you just deliberately go and look them up. So what is a statement? A statement is a unit of code. Print 1. That's a statement. It would print out 1. X is equal to 2. That's a separate statement. Print X. That's a third statement. Pretty much you want one statement per line. Can you trick it into doing more than one statement per line? I believe so. Can you make a single statement span more than one line? Yes, you can. I think we figured that out with the print statement last semester. Like if you do this, print hello, comma, darkness, comma, my old friend. There we go. We're either Simon and Garfunkel fans or Disturbed fans. So here we go. And then it says, hello, darkness, my old friend. So you saw that it spanned several statements, several lines, but generally one line per statement. If you ever see me break something up into multiple lines, it's just because I've typed something that went so far that we started scrolling to the right, you know. I don't really want, you know. Am I going to wind up typing something that long? Probably not. But if I had to, I could. Here's how you break up a statement that's not broken up by commas. The reason this worked is because of the commas. I can't just do this. A is equal to 1. It's not going to accept that if I run it. You could type it along with me, but it's not going to work. It says invalid syntax. I really want to get that to work. I'm disappointed it doesn't. Well, I didn't mean to close idle. I hope so. Yep. Thank you for asking. You're my new favorite person. Here we go. So I got idle back open. I'm just going to, rather than go searching for the file, I should be able to find it in recent files. There it is. Alrighty. What was I about to do? I was going to show you how to break something up. You use the backslash, the one above the enter key. So A is equal to backslash 1 and 1 being on the next line. That lets you break a statement up into more than one line. How often do I do that? 0.00001% of my time, if that. I'm going to delete that stuff. I'm not going to ask you how you break something across more than one line. Just know that you can, and if you ever have to Google it, you can. So, operators and operands. The operators are the special symbols that manipulate data somehow. Plus actually has two meanings. Plus will add two numbers together, or it will, quote, concatenate the strings. What do I mean by that? I'm going to go back to my shell, run shell. And by the way, if your shell's too cluttered, you can always close it and then just reopen it with run Python shell again. Now that I've said that, I forgot what I was talking about. The plus sign, concatenating. Right, so 1 plus 2 is 3. Put quotes around the 1s and the 2s, and it's a whole nother flavor. 12. Why? Because by putting quotes here, these are strings. You can't do math on strings. The language is treating strings completely differently than numbers. It doesn't even know that we stored numbers in there. Why? Because we could have put words in there instead. Like the plus Beatles, like that. So plus sign used with strings is called concatenation. Used with numbers like that, it's called addition. What about 3 times 4? 12. How about 3 times a word, like 4?
Is that why it has, like, when it prints out, it has single quotes? Because it's letting you know that it's a string. It's seeing it as a string.
Right. The language, some languages use apostrophes to mean one thing and then double quotes to mean something else. Python uses them interchangeably. I could have been teaching all along name is equal to single quote, Joe. But exactly, it printed this out with quotes around it because it was a string. It was a result of concatenation. Star star means exponent. If you want to do 3 squared, you do 3 to the power of 2. 3 star star 2. Don't put a caret. If I ask you how to do exponents and you put a caret, I'll start weeping. No, I'm kidding. You know now that star star means to the power of. Let's prove it in the shell. Go back to the shell. 3 to the power of 3. Nope, that's just 3 times 3. Yeah, let's do that first. 3 times 3 is 9. But 3 to the power of 3 is 3 times 3 times 3, so it's going to be 27. If you want to do scientific notation, you know, you could do 200 times 10 to the power of 5. Now let's make it 2.1. That makes it look more like your standard scientific notation. And that's 200,000. Yes, sir.
Someone get it 1 3 times the string gives me a pattern of 4.
Isn't that silly? That is really silly. No other language I've used has ever done that.
Would you ever just
It multiplies this string that many times. And the only place I can imagine that being useful is if you're trying to make a whole line of spaces or a whole line of dashes. Like you could do this. Print 80 times a hyphen. And it's going to print 80 hyphens. That's kind of cool, but I can't see any other need for it.
Is that still concatenation with it?
I don't even know what they call it. It's a form of concatenation because they're concatenating that against itself. Good question. Why don't we Google that up real fast? Star string Python. Let's not. When I run across it, I'll remember. So what is an expression? An expression is a series of values, variables, and operators. Or it's a series of operands and operators. Operands being the things that the operators work on. Here's our operator, the X sign. So 17 is one of our operands, and so is X. So that's an expression. And an expression is evaluated as Python comes across it. If you say A is equal to X plus 17, the X plus 17 will get evaluated and then copied into A. Or if you do print 3 times 4, 3 times 4 is the expression, it will get evaluated to 12 and then printed. If you type an expression into interactive mode, it evaluates it on the spot and then goes ahead and displays it. Whereas Python in a script does not. If I go here and I type 2 times 3, that's okay, but it's not going to print it out. It's just 2 times 3, you know. But if I do that in the shell, 2 times 3, it does print it out. I'm going to delete that. I don't want that 2 times 3 there. So order of operations. The rules of precedence. Junior high or whatever, you probably learned that. I need a larger font. Thank you very much. That 2 times 3 plus 4 as opposed to 3 I'm botching this. 2 plus 3 times 4, like that. You may think that you just solve them left or right. You don't think that because you've had junior high and you've had a programming course already. Instead, this is evaluated where multiplies happen before pluses. So 2 times 3 is 6, and then you get the 4, and so that's equal to 10. If we tried to evaluate this one from left to right, we would have gotten the correct answer, but it's purely by accident. 2 times 3 is 6, and then 4. So, yeah, that time it worked. This time, 2 plus 3 is 5, times 4 is 20. But if I go and I type that into the shell, two plus 3 times 4, it's sure not going to say 20. Why? Because, again, multiplication has a higher precedence. It gets done first in the equation before addition. I don't know who made those rules up. Newton or, some old mathematician decided the order of precedence. Could they have been done in other orders? Yeah, they could have. It's not carved in stone. It's not a biblical thing that you have to do these in these orders. If you have any question whatsoever, you can use parentheses to change the precedence. So if I really wanted that 2 plus 3 to happen first, I put parentheses around it. 2 plus 3 times 4 is 20. Yes, sir.
It's only showing like 4 orders of operations. Is that all there is, or is that just like one function?
Good question. Let me see if I can do the order of operation from memory. PIMDAS. So, P being the parentheses, highest. Anything inside parentheses gets evaluated first. In order of the innermost parentheses get done before anything else, And then you have E, which stands for exponent, which is star star. I need to go put letters in front of these. That's P, that's E. And then MD stands for multiplication and division. And there's actually more than that. Along with multiplication and division, star and divide, there is that, and there's that. 2 slashes means floor division, which rounds down, and percent sign means modulus. We'll hit those in a minute. So multiplication, division, and floor division, and modulus. We'll talk about those in a minute. We'll demonstrate floor division and modulus for those who need a refresher. And then lastly, we're left with AS, addition and subtraction. Let's see what the page had to say. Yeah, exponent. Okay, parentheses are first, then exponentiation, then multiplication and division. They did not mention floor division and modulus, but they have the same. And then addition and subtraction. So, why does that seem like 4 when they put it that way and we came up with 5? 1, 2, 3. Is it really only 4? P, E. Yeah, okay, that's right. Like that. So there are 4. A lot of these we know what they mean, or you're going to memorize. Star star means exponent. You know what multiply and divide mean? I hope. Floor division. Rounds down. Go back to your shell. 3 divided by, let's do 5 divided by 3 is 1.6, whole bunch of 6's. 5 divided by 3 is 1 because it rounded it down. Why do you care? Well, sometimes you don't want a fractional result. Like if you have a certain number of pennies, I have 5,000 Let's do that. Pennies, P, is equal to 5,432. And then I want to count and give them only dollars and cents. So dollars is equal to 5432, floor division, 100. And so if I print out D, yeah, I goofed that. I should have done D is equal to P divided by 100. I don't know why I typed the number. So then when I print out D, this many pennies is equal to this many dollars. But say I wanted whole numbers, then I would have used I would have used floor division. So dollars is equal to P / 100. And then when I print P out, when I print D out, I get $54. How do I get that 32 out of it now? If I want to print out how many dollars and how many cents, that's what modulus is for. So if dollars is equal to our number of pennies floor divided by 100, then our number of cents is equal to the number of pennies modulus 100. Now if I print D out, $54, I print C out, 32 cents. $54.32. So what did that do? Modulus means remainder of. 4 modulus 2, 0. Because there's no remainder. 4 is an even number, so if you divide it by 2, no remainder. 5 modulus 2, you do get a remainder. Got a remainder of 1, right? An odd number divided by 2 has 1 left over. What's 9 modulus 3 going to be? Yeah, people said 3 because that's what it looks like. And then you corrected yourselves. Good job. It's going to be 0. What's 10 modulus 3 going to be? It's going to have a remainder of 1. 11 modulus 3 is going to have a remainder of 2. Some languages support modulus with floating point numbers. Some do not. Let's find out what happens if I type 11.5 modulus 3. So I don't even really understand what that means. I guess I do. 3 goes into 11.5 3 times with 2.5 left over. So you can do floating point modulus, but the idea is kind of odd to me. So that is floor division. // 5 divided by 2 is equal to 2.5, but 5 -- 2 is equal to 2 because it rounded down. That is equal to modulus, also known as remainder. 5 modulus 2 is what? We already did that example. 1, yeah. And then 6 modulus 2 is 0. Yep. All right, uno momento. We will do some Python tutorials from chapter 2. Read the chapter, it's a bit long. But it's important, it introduces very important concepts, which is review for a lot of people. Variables, functions, which we haven't even gotten to, // and the asterisk. Then I want you to do some tutorials. The tutorials out of the book is when they give you code and you're supposed to type it in. So if you have the physical book, you're just going to open to that page and you're going to type in the code and you're going to get it to work. Specifically, 3 problems. volume1.py, initials.py, and initials2.py. Then there's a reading assignment. I don't care if you actually type it in, but I want you to read it very carefully. And then make sure you know what // and % do. Type that in. And then I say, please submit your screenshots. What does that mean? How do you take a screenshot? Well, if you're a Mac user, you do it in a different way, and I'm sure that you know how to take screenshots. If not, you can Google it up. If you're a PC user, here's what I want you to do. Say that we have a Python program, and I want to prove that it works. So I run it. It gives me some output. Great. You might zoom it to get as much as you can on it or whatever if it scrolls off. Now hit the print screen button. I want you all to do this just for fun. A couple of you may not have taken screenshots before. I bet 80% of you have. Hit print screen. And if you're using Windows 8 or Windows 10, I think it automatically saves that somewhere, which seems kind of as a security risk or something. I could be wrong with that. So then you want to open Word or Paint or some kind of program where you can make something that would save it. I'm just going to load up Paint. So in the start box, I'm typing Paint. I could have launched Word just as easily. So I hit the print screen button, then I go and I open a document editor of some kind, and I paste what I just screenshotted, and there it is. So do a save. However you do that with Paint. Word, you know, if you want to use something more familiar. And then just give it the name of the Dropbox or whatever, you know. If this is, you know, tutorial 2, whatever, homework 3, whatever we're going to call it, then give it that name. And so that'll be what you upload. That makes sense? Okay. So that's one of the homeworks. It's probably enough to give you. Yeah, why don't we just stop there? Because we haven't made it all the way through chapter 2's. Pardon me? Well, you'll see it real soon. This is from an older class. I'm going to need to download it and change the assignment number. All right, so it's homework 0 is what we've done. This is going to be homework 1. Chapter 2 tutorials. I'll copy the Word doc into it in just a little bit. And so that'll be due a week from today, which is Wednesday at midnight. And I'll give you your day grace period if you don't get it Wednesday, if you turn it in on Thursday. I don't ding you for that. All right, I forgot to put that in the right category. Let's make a Dropbox for what we did today, for the in-class stuff. I did not call the last one in class A. Usually I number my in-class, well, I guess it's not numbering. I enumerate my in-class assignments with, well, botched that totally, with letters. So that one that says August 22 needs to say A colon. And then we're going to do a B colon, or a B dash, which is August 24. Chapter 2 stuff. Alright, if you refresh your Dropbox, go ahead and find the Dropbox and upload the PY script. We should be good to go. So let's call it a day. If you have any questions working over the weekend, go ahead and get Python installed if you don't already have it. I know most of you do. And work on the tutorials out of the book. If you haven't bought the book yet, consider getting it on Kindle or something, because you can even get a Kindle reader for Windows, you know. That's kind of nice, so that you have the textbook in front of you on your computer at home. You don't have to have a device to read Kindle books. All right, before y'all run out, I need to take roll. Let's stop this.